Over to you, Norbert.
Okay, yeah. Thank you. Good evening. So thanks for having me and bear with me. I'm not sufficiently a user of Zoom, so if navigating looks a bit awkward, it might be. I've never used it the last years. So yeah, so let's get. I didn't know exactly what crowd I have to expect. So what I will try to do, I want to do some hands-on stuff, of course, because I think that's where it gets more interesting. So I get a little bit of context about me, about soil and where it gets through, and then we get into this database topic. So I hope this matches your expectations. And for me, it's always if you have a question, just well, not interrupt me within the sentence, but maybe if you would wait until the period, so you can always ask questions. So because I think I'm not like a one-man show presenting here. So if you want to know something, just chime in or write it in the chat. I managed to open the chat window, so I can look at it. All right, soil. It's a database. So a database basically is something that stores data. So it's the long journey, not losing your data when power gets off. Um, and my story is rather that I never wanted to do database stuff. So it's the same as Linux administration. I never really wanted to do it, but now I do it all my life. So, and the database was rather coincidentally that I got to it. Who am I? So, yeah, um, I discovered or I heard Smalltalk the first time 95, a colleague mentioned it. Was the same time when I just got into Java. Um, and then 10 years later, so there was a lot of tinkering and thing with Smalltalk. And then in 2005, a friend of mine wanted to do a startup and I was saying, okay, I'm in, but let's do it with Squeak. Yeah. So because that's more fun to do. So this makes a lot of celebrations in this talks because this is 20 years of professional small talk for me, at least. Yeah. Why soil exists is because right now I have a company which does, well, you call it low code, no code tool for business processes. So the second line I like to call it business IDE. It's just to shortcut a lot of the software development. If you need a little database, something behavior and something for presentation, which is most small to medium software is made of, you can just click that on a website. So this is just for getting the business forward, especially in Germany where we uh, under digitalized, I would say. That's a not world championship, but from the other side of the table. And it's running for quite a few years in this active grid. So I just made something like the snapshot from 2 days monitoring about the facts about the database, where you can see the number of transactions that have been done, objects being materialized, and cluster records being read from disk. So it's just a visual to show you that it's live, it's being used. This is from today, and it carries quite some load. So my journey started in '95 actually, when we talk about databases. It was like a C64 where the index was like a paper book where you wrote, you had to fast forward to the counter, and then you had records. So it was I would just remember it was my first encounter doing a database was 40 years. So 10 years later, I got really into database system. The database system available then was Mini SQL or MSQL, which was a single threaded database, but was the one available for free. And so we used it a lot. So the fun fact I put on the bottom, not sure if for whom there's a bell ringing, but the MySQL team, they wanted to license the MSQL, but they didn't come to an agreement. So MySQL built its own. It reminds me a bit of the story about Smalltalk and Java, because as I heard, Sun wanted to license Smalltalk and they didn't get the agreement over, I think, $100 or something. And so Sun started to do their own programming language, and the rest is history, we all know. 10 years later, that's exactly the 2005 when we did the startup. had some doubts about the SQL entity relationship data model. And then I just got into what's happening on Smalltalk. There was a goods database, not sure who of you remembers that. I re well, I was thinking I really liked it, so but there was a reason why I couldn't use it. I really liked it, but and I cannot recall what was it. Then Magma, I think everyone was in the Squee community knows that there's Magma exists. I couldn't use because it was too slow. I ended up using Clorp, which most of you might know. So I even ported one of the Squeak versions from Visualworks to Squeak. But yeah, with the proceeding of all of those objects and object relational mappers, it ended up that I stopped using object relational mapping and SQL altogether because yeah, because the if the soil is a database for fun and profit, so I was always the mentioned that SQL and this kind of setup kills your fun. So I stopped using it because I'm just saying that object relation mapping usually does not work in most things you want to do. Yeah, 10 years later, there was then the next progression, saying there's MongoDB, web scale and all this stuff. And in the Smalltalk community, especially in Pharo, there was a object to document database mapping, which is called Voyage. And I was using this along, which already fits a lot of better. You have nested objects and stuff, so it fits the object model a lot better than the sequel to me. It's my opinion. And then there come ActiveQuit, the company I just founded, and it was 5 years ago. So not sure if any one of you had the chance to see me on ESEC to have my talk. So there we just started, as you always should start, image persistence. Then we had this Voyage and Mongo. Then I discovered Omnibase. Not sure. I think a lot of people might remember Omnibase as well. And when I discovered, because I had a false imagination about what Omnibase, I knew the name, but when I discovered that it was all written in Smalltalk, then there was this, when something drops, you're saying all the dissatisfaction with SQL and everything I wanted to do. I was a Gemstone user for a long time. Then we're saying, okay, there's something lightweight at your hand. It's purely Smalltalk, so you can tweak it, you can make it. So I got into Omnibase. I even maintained the available code base, but could not proceed for multiple reasons. And so well, actually, I prepared a talk for ESEC, I thought 2022. And then it was just that my talk was gone because the original author contacted me, said it was never open source and there was a lot of things going on. And so instead of having an Omnibase talk on ESEC, I made an announcement talk for Small Soil because just saying, okay, let's do it on our own. And now for over 2 years, Soil is running and we use it in our company. All right, so okay, that's the quick overview. What's my history and how I'm always dealing with databases and for us small talkers. So I want to just give another context dive in this thing what persistence means. So that the root of all of this is that the industry never came up with a memory that is big, cheap, and non-volatile. We always know we have either main memory, which is fast, super fast, which is not cheap. And when power goes off, it goes down. And we have disks which are way slower, but way bigger, and they're cheaper. So that's why we need databases to mitigate that effect. When we start with an object, with a project, I always did this even in ActiveQuit. You just use image persistence because from a object graph standpoint, this is the best way to save your data. So there, you just hibernate it to disk as we do with our images every day. And if you want to continue working on that, you just pick it up and everything is there. So that would mean it would be kind of a singleton database because usually you put your data into a singleton and then you save the image and then it's preserved. So what's the problem with the image? And then, yeah, in the image, of course, you make your own application or business model, which contains objects. So, and then you store that, but the big problems with the image persistence is something called, I would call frequency. Frequency means the amount of stores you can do with an image. So that the biggest problem with images, it's huge. So even for the simplest change, which like changing a string with a typo, you will have to save the same image, the whole image. The second problem is that in order to have a sane heap storage on disk, the VM needs to stop the world. So it's just like in the moment you save it, the VM will stop all the processing in order to have one snapshot of the memory, which is also there's two things which are not good if you have a software product. These are not good if you have requests coming 24/7 in. So in order to mitigate the problem, you can have the, well, in smaller Squeak and in Pharo, there is the object serializer called Fuel. So it can store a lot of things. And then you're saying instead of saving the whole image, I could store just my model as a fuel dump, which goes way faster because it's smaller. But the problem is that fuel is not stopping the world. So usually you have that still it's big. You save your whole model, even if you change only tiny fractions. And while you store it, if an object is altered, you will end up having a corrupt store of all that stuff. So it's also not preferable for an online service. The other thing which we need, you might see in the image that there is some space, is that, and that's where we enter the soil space, is that we're saying, okay, the whole model saving is always, it's not efficient enough. So what you want to do is making, well, a close boundary around your changes and store them in a concurrency safe way, so you don't have to care. And soil does it in a way that this is just a visualization of the object graph, where the light blue ones are the ones which we call a cluster. So you see that what we do is we cut all the model graph into smaller subgraphs. And at the edges, we assign addresses, soil internal addresses to it. So now you have, from your big model, you have always either leaf nodes where there is no other object referenced, or you have something which is, we call it a root object in soil, that has its own address. And then you just store the cluster with that fewer objects that point logically to their counterparts. And this is how we can cut a bigger object graph into a lot of small pieces, allowing us to, if there's a modification, only store that little subgraph, but still don't have the problem like in ORMs or something that I have to map all the stuff like collections and stuff, every fancy stuff we might think of. We just can store still because it's still a graph. It's just smaller, and the size of the graph is into your control. So you control it yourself. So the serialization to disk. So because that's the one thing a database does, or every serializer means I have this net of objects in the heap memory, and then I make a byte stream out of it. So I can store it on the disk. So soil tries to be the most simple and the most flexible way to achieve all that stuff. So that means there's only two cases right now. Either there's a general case where we're saying we can delegate the serialization to the class layout. If you see it here, self-class class layout, then you can see there is indexed objects, there's variable length objects, there's all kinds of objects. And as these are the layout is objects, there are objects on them themselves, they can decide better how to store something on disk. On the lower part on the slide, you see that you can implement that for special cases like a string, because if you would have a generic serializer for a string, this will serialize a collection of character objects, which I think it's easily to understand that this cannot be done efficient. And so we just make a special case. So strings, numbers, and special objects are serialized a special way, and every other object, and really every other object, is just serialized according to its class layout. So this makes it possible to store almost all objects. So including, well, where we added clean blocks is also possible. So this is the next thing which we have, that we can have clean blocks. If you don't know what clean blocks are, clean blocks, so the enclosement of a closure, enclosing its environment, means that everything that is visible while the closure is being created is stick to that closure, so you can still access it. So one prominent example is self, or a temporary variable in the method. And a clean block is something that has no reference to the outer world. So that means everything that it gets via its arguments. And for these, it's much easier to store. And I'm not sure, I think it even works right now, or we are close to the point where it's possible. Full blocks is a different story. There's a question on is this kind of like a pure function? Yeah, you could say so. If a pure in the sense that you can, I mean, pure, I'm not sure if you have pure function means, I think also write only, so assign once. So that's not the case, of course. But everything that there is no side effect, that's exactly the point. That you don't have references, so there's only one return value, and the block cannot access anything outside of itself. So it's kind of a pure. I hope this answers the question. So full blocks is right now, I think the exception. So according to Marcus, it could also work, even if it's really expensive. There's another question about soils multi-user. It's no, but so we can wrap that up later, because that's a question that comes up often. So it depends on what you call it, multi-user. So yet again, serializing, it's possible. Full blocks, I think it's an exception right now. Maybe we will do it, but everything else can just be stored. So it's a general serializer or database. So the overview over the architecture in Soil is that a transaction, every transaction has its own copy of objects. So that's the thing what you had in image persistence and fuel. You always have, usually, and even in Voyage, you have some kind of central objects in the heap. But these impose always problems in concurrent access. So you have always a problem that everyone is stomping on each other's feet. So in Soil, every transaction gets its own set of copy of the objects. So you can have multiple transactions with the same object in memory, but they don't reference each other. So they isolate it against each other. Soil uses MVCC, which is nowadays, I guess, the state of the art, storing objects in a database, or even Postgres, they all use that. So it just means that every time you alter an entity or an object, you write a full new copy to the end of the file. So there is no in-place writing. So you have a bit more space that you need to clean up, but it gives you certain securities about not making things in parallel and making all that stuff. So I will show later what is the consequence of this, which is pretty nice. So then everything you have to say in a database, it has ACID transactions. So because that's one of the things you need to have. For those who don't know what ACID means, is I don't even can recall. So, but is the atomicity. So that means the A is atomicity. That means all goes on disk or nothing. So there is no half written stuff. C is, I forgot.
Yeah, I forgot as well.
Consistent.
That's it. Yeah.
I is isolated, which means just that you have, no matter how many transactions in which time frame, everything is isolated from each other. That every save for each transaction goes individually without interfering, and that the best isolation is even that the the order of transactions doesn't matter to the end result. Durable means that kind of the consistent and isolating point is that no matter when the database breaks down, atomicity and consistency is not focus. So it's a system that whenever something goes wrong, you can recover from that problem, either in a progressive way, just to do it again, or to roll back. So always that this guaranteed asset always means gives you the guarantee you can go from one sane state to another. And the usual thing is that you attach the commit and abort of a transaction to exception handling in Smalltalk. That means if you return, you commit, and if there's exception, you abort. It just means that in the usual happy path that we're programming, so you alter data, and in the exception case, you don't alter bogus data. Soil has also binary search indexes. So this is needed if you have a lot of objects. We have a lot of graph, but then you imagine you have a dictionary with 1 million objects. This can't be fast if you have to read in all the dictionary and all that stuff. So there is binary trees. We have two implementations. The one is skip list. The other is B tree. You might know. Everyone knows that. I'm more in favor of the skip list. The characteristics are pretty similar. It's all, we call it O log n. So the request is that the time you need to index is log n times the number, the amount you have in a database. So it gets smaller the more there is in. So if it's 10 million, it's not much lower than 1 million. And then what I did from the beginning is that Soil has object segments. That means that there is multiple logical spaces where you can put your objects. So there is right in the moment, there is 2 segments. There's segment 0 for all the meta stuff like behaviors, and segment 1 for the objects. But you can also, if you have a use case, you can have multiple segments where you can have objects stored in different segments for a certain reason, maybe. So I have ideas, and I just wanted to put it in because that's really hard to do afterwards. So I did it from the beginning. I'll tell a bit about FutureBits because after that I want you to change into a Pharo image, and then probably we get more into the hands-on session. So maybe you don't come back if I manage to get out of this presentation mode. Yeah. So what we're working right now is that I'm new, Markus and me, I think we're new to database technology. So there's a lot of stuff copied from Postgres, from Cassandra, from everywhere. And the first approach was to dictionary-like. So everything indexes, everything was thought like a dictionary. And then we thought, okay, at one time you need something where we can have duplicate keys. And then you see, okay, the assumption or the model we had in our head is a single key stuff. So we're now repairing all of that. We're close to be finished. Then you have indexes that allow multiple duplicate keys. With that, you can make the second point, which is secondary indexes, which is in all databases. Usually you have all your objects, and then you're saying, okay, for this property, I want to have a special index for faster access. And with duplicate keys, so duplicate keys, you can imagine you have address database, 1 million people, and then you were saying, I want to sort by last name. And well, it's quite probable that there is at least a couple of last names which are the same. So you have to store that. Secondary index, which means just you have your full-blown index, and then you can make a subset of any sort of secondary saying, I have the whole objects, but you have an index for first name, for last name, for whatever, to guarantee faster access. Lazy materialization is something I have on my mind because we can talk. No, I can do it now because if all this cluster thing is sometimes it's too huge. So because you have your objects, you're saying, okay, I don't need a special object, standalone object for this in the database and address and all of that stuff. But you also don't want to materialize all of that stuff. Lazy materialization will just postpone the materialization when you access it. So it's kind of a proxy thing that you're saying, I'll keep the byte array around until I touch the object, and then I materialize it to real objects and work in it. So which will save a huge amount of things which that untouched objects don't need to materialize. Indexes on the heap is something we failed to do because there was the announcement that the soil v4 will not be backward compatible. That was the plan to put indexes on the heap, which just means I copied a lot from SQLite, but then you copy all this notion that you, in the binary on the disk, you're saying, here is that information. Then you have this header and everything in a configuration you write in this first header binary until you recognize, but it's still an object system. Yeah. So still an index could also be an object on the heap. So we tried to do that, but it's far bigger than we thought. So we just rollbacked and did something else, which is a bit lighter. So Mark Dirty is something I will talk soon in Pharo, but this will go away. I'm just decided that we will use an object state pattern so it can track itself which object changes and which are not. So you have less low-level API to use in your API. Then garbage collection, I have a really naive and first approach of garbage collection, but it's really complicated if you want to do all the stuff. It's really complicated. So we have one because we can do backups, and by doing a backup and replace the old database with the new one, you have garbage collected it because the backup just backs up all the connected objects and all the newest versions. And finally, my last talk in ESAC was that my plan is to make Soil a distributed database. So there is a plan which with all the parts that I need in place. I just need to ramp up testing and all that stuff. And yeah, this will be for future talks. There will be stuff that we can have this in a distributed way. In the context, so there was a question in the context of database, what does garbage collection mean? Well, the answer is easy. It's the same thing. So the more I do in the databases is that the VM allocates some memory, yeah, and then you have objects laying around. And in a typical mark and sweep garbage collection, what do? You have these special routes, we call it. So there is some objects which are known to the VM, and everything that is referenced from that object is connected, or how's it called, connected or live. And so what you do in a mark and sweep is you have a second segment for the memory, and then you just go all the connected objects and copy that over, and then you throw away the other segment. That's garbage collection. And in the simple case that I did, the database does the same. It opens a second file, and then it just follows all the references, copy them over, and then it removes the old heap and removes it with another one. I have a plan for something which is called incremental, so which will allow to make Soil a 24/7 database because you could garbage collect just in the background while you operate on it. So, but this is all plans, and I'm not sure if I'm not too old, but I'm not sure if I get it this lifetime because it's such a lot of still interesting stuff. Distribution, the Rhizome project, that's something really what I will do next year for sure. But for the rest, well, if we need it, I have databases which are, I think, close to 200 gigabytes in size, but I mean, disk space is usually cheap. And there is it's 64-bit, yeah. So there's nothing telling you that in a file, if it reaches 100 gigabyte, things work differently than in something which is 2 kilobyte. All right. So much for the talking. I would say,
Nice.
I hope it was a bit interesting. So I'm not sure how much time.
No, it really is.
went.
No, it really is. It's cool.
Just to give a bit of context, because you never know how people approach databases, because there's a lot of myth and stuff, fairy tales and anything about databases, because it's just usually a black box. And the motivation for me, because I had this discussion with Dale Hendricks on Gemstone, is I used Gemstone for a long time because it was one of the stuff. But what the thing that resolves so much, or makes a pain reliever, yeah. So this object database. So Gemstone has its other obstacles, but I wanted to have both. Something flexible, a Pharo image that you can have something small that you can move around, and on the same time you can store objects to it. So it's not as cool as Gemstone for sure, but yeah, it said, oh, I managed to get out. So can you see the Pharo image?
We can. Yep.
Great. All right. So this is a stock Pharo 13 image I downloaded today. And the first screen is just that's the thing, and that's just the handover from the Gemstone and everything else. It's the only thing that's needed to get the database, or how we can say to turn your image into a database, because that's the plan that you're saying. All the what always struck me was that people, I mean, everyone's complaining, like laughing, haha, this childish database or something. But then they have computers, and then they send everything over the network. So you serialize all in something like a DSL, like SQL, and then you send it over the network. And one of the fun stories is always like, if you ask people, why don't you just read your data into memory and just use your programming language to operate? And then everyone's laughing, ha ha ha. This is not possible. But then they install a database. They send everything over the network. And what does the database do? It loads everything in memory in order to have quick access. So you have really something like a nonsense, like you have your programming language, you map to inferior DSL, you send over network, you explode it back to something structured, and then you have something that stores in memory. Saying, okay, I think that's not something I want to have. And then they have a central database, and then they always ask, what kind of computer do you rent to have your database? And the answer is always the same, no matter who I ask. They say the biggest. Yeah. So it's just a central part, and then you see there's not even a resilient way. Most services that have this central SQL server, if that goes down, everything goes down. All right. So
your description just then would make a nice slide in the previous slide deck, actually. That whole kind of journey that you go the traditional route versus what is a more direct. Why not just have your programming language operate on the data that's already in memory? It'd be a nice slide.
Yeah, if there would be 2 hours.
Yeah.
There would be a
we
lot
can
of
ask ChatGPT afterwards to like just draw you that diagram, and there you go.
It's just a clickbait you need for your slides.
Yeah. All right, so this is some code. I just asked ChatGPT, give me a CSV with 50 superheroes, 5 qualities. That's the best I always do. This is my modern lorem ipsum. It's just like create me that CSV file with tons of data, and it's pretty good at that. So it's just all of this is just that we have a few objects to play with. So we have a heroes that has power, origin. It maybe is part of a team and has a certain level, some data. Yeah, so
cool.
It's a bit more interesting with if you have that data. So if you have that data, so coming from the image persistency, that's always what I'm saying. Don't think even about soil. Wait, the network was initially created for the yeah. Do you feel the need to classify data differently as your needs evolve? I don't understand that. Can you rephrase, or we can come back?
Come back to it afterwards. I think go through your example and then.
Yeah. All right. So saying here we have our objects, which we will have, well, in image persistence, we stick them to a singleton, and now we're just saying, now we get for real. So what do we have to do? So we just call it soil, and then we do soil create on path heroes. And then, that's basically it. So if we do this. Oh, it already exists. Okay, so then we take so this is what you can start from fresh. So if I play around, I usually do this. The problem with initialize is initialize file system. So now you do this, that you can repeat over and over because it just deletes the database and then creates a new one. So you make that, and then you see here, there's something you see, and then you have the database. So you have created that. So if we look into the heroes, so just a bit to get custom. So this is the database. So there's a control file. This is the central information it needs to operate. The journal I will get into soonish, which is, oh yeah, we didn't have a transaction, so it's empty. Then there's metadata and there's the segments. It's all just files and directories. You have the index file and objects. So it's a bit of structure. So when you create a database, it just makes it scaffolds a little file system hierarchy and initialize the files that it needs to operate. All right. So then we make a transaction. And as a special objects area in a VM is like the special object area, you have one place where you're saying this is known to the database, and this is the database root. So there's one object usually you put on the database saying this is the root, and from there, everything that gets referenced is there. Then you make the transaction, you have that, and then you just say root heroes and commit. That's it. When you get this, you get back the transaction. You see here, I can say read. So every, you see read 0, write 1. That means the version. So the database has always a sequential rising version. So when we create it freshly, it's version 0. And every time we commit a transaction, the database version will increase once. Then we can make a second transaction. And then we just read the root object and display it. And there they are, the 50 heroes again. So that's basically what you need to use so. So I'm saying, I have my, yeah.
The transaction, like the TXN, after you've committed,
Yeah.
can you still continue to use it, or is it effectively ended and
there is, so usually you don't want to have a reuse of the commit because there is certain things you don't want to have, but there is an extra call. If you commit and continue, then it keeps the data in order to continue. So it's a deliberate act to say either it's commit and finished, or commit and continue is just another method call, and then you can use it.
okay. I suppose in normal usage, you just keep creating transactions, do some work, commit, and then throw them away and
yes,
create another one. Yeah, okay.
It depends a bit because if transactions get too big, there's troubles. But if you have like chunked committing, then you don't want to read the old stuff all the time. So it's, yeah, there is, the one is good for the one case, the other one is good for the other case.
Okay.
So I never use commit and continue actually. So, so that's your basic soil skill that you need. So just wait. So, we did that already. Okay. So we have that. And now we have what we did is that we have a collection with 50 heroes and we saved all in one cluster. So, okay, wait. A bit in-depth information. So if we inspect soil, yeah, then you see there's more tabs to here. Yeah. So in the control, it displays the information in the control file. which just means the database, well, this will go back to 1. It's a database format version. It's just something we keep to in order when we really change the database, we can warn the user that now he needs to convert something. The database version is something I talked about. This will be increased every transaction. The application version is a placeholder for your versioning of your database, of your application model. So if you're saying, okay, now we need something to change, I can, there's another slide I forgot. Because there's a migrator in Soil that you can use to migrate your application model. So what we do in ActiveGrid is just, we have a Pragma-based migration scheme, and then we just make a method with the Pragma for the next version, and then you get a transaction in that method, and then you make the migration. And it's just like if a request comes in and it opens the database, it checks if it needs to be migrated, and then it migrates, and then it answers the request. So it's just like transparent database migration, if it goes fast, of course. So, but most things go pretty fast. The checkpoint is a thing which I'm not sure if there's time. So checkpointing in database, that's the durable thing that you're saying. Basically, in a database, you write everything in a journal file, and you make sure that this is on disk, and then you commit to the heap. And so you have all the scenarios. Power goes down while writing to the journal file or writing to the heap, and there's in all the combination, there's always a way to recover from that. And Soil does this automatically. So if you like Postgres and all, if it sees that it didn't went down cleanly and you come up, then it tries to recover all that stuff automatically. Then there's metadata. It's just a thing that's also extensible in Smalltalk, that you can have your own. It's like a little dictionary where you can put out of transaction information. And a few things is like timestamps. And here, as we committed the transaction at 4 minutes ago, that's just the last modified timestamp is that. A bit more interesting is the journal. So we have one journal with the file name 00 because it's our first. And if you click into, we get the transactions. When they created, how long that took. And in that, we get the transaction log. So you see, you can inspect everything that was done to the database. This is called in other systems, it's called replication log. So every database has that. Journal, in Postgres, it's called write ahead log. Journal, no matter how you take it. So you see there's always a begin transaction, then there's a new object. You see 1.1, this is the root. So this was the ordered collection with all the heroes. And 03 is the class, because now hero, the database didn't know about hero, so it stored the class information in the database. All right, so as we saw, here is so there's only one object entry that we wrote, as if we make it a second time. And we make the heroes root object. So that's something I told before, that a root object is something that has a database address. So it's standalone. So if we make that, then we see in inspecting Soil that there's a lot of objects being created in there. So now we have, the problem is, and I didn't figure out, because if you read the collection back right now, this one, it's a collection which proxy objects. So no hero is basically loaded. It just points to a network address, and it's a proxy which users does not understand. And the moment you step into, it means you use it. It's loaded from the database. But with the inspector in Pharo, it does so many things on the objects that I did not find a way to not resolve the proxy. So I'm out of a way to prove that that these here, the dictionary, these are proxies, and these are resolved right now. So, but that's what what Soil does. No matter how big your graph is, if you enter the root and you go in the inspector, you can just click throughout the whole database, because every time you will get a cluster with proxies, you step into the proxy, it will be resolved, and then it goes further and further. It's the same way as you why object-oriented databases and applications, web applications fit so perfectly, because you just transfer, usually you navigate over getting to a reference to another object. And so you have, no matter how 1 billion objects, if you just have a path that needs to load 20, then you load 20 objects, which goes really fast. Oh, first someone's new to Smalltalk. Oh, the do-it-check. I'm sorry. So here it's a code editor. So if you have you can have any expression. So then you can have Command D on Mac. I think it's Control D on Windows. Then you will execute, but you don't see something. If you use Command P, then you see the result right after the object. And there's also Command G, and that opens that inspector on so these are kind of Miller columns. So because you can go, as you saw, you can go further and further. You can go into here and it shifts. So you could even, it doesn't work that good, make it a 3-pane thing, but I think it doesn't work pretty good. So, but that's something I always want to have, but I never get. So the 2 ones is better.
I never knew you could do that. The Miller columns at the bottom. Well, you learn something new.
Yeah, there was years I didn't know it works, and then I used it, and then I saw it didn't work. It doesn't work. So I better not know. So all right. I hope that answered the question. It's just a shortcut. Yeah, maybe I assumed that it's all Smalltalkers and all old hat. Are object references resolved lazily? Yes, that's what I told with the proxies. So that means if you remember the graph with the cluster, that means if you serialize an object and it looks at every reference and saying, are you a root object? Not root like root object. Then it stops traversing and saying, okay, instead of storing the object, I'm storing the reference to the object. And so if you load it and you see, I have this object, I create an in-memory proxy pointing to that address. And if it doesn't understand it's called, it just goes to transaction saying, give me the object for that address. It wraps in the proxy and then it proceeds on that. So that's what I told, but what I cannot show is that if I do this, yeah. So these proxies are loaded, and if I go into there, there's lazily evaluated, so you don't recognize. So before we optimize the proxy, you could see that there's a proxy, but now we cannot. I don't know how to tell that this is a proxy. No. I decided not to use become. Become becomes often a problem. So and become is not that fast. So if you have a lot of objects, so it's just a proxy is object proxy. So an object proxy has here, if you does not understand, it has a real object. So wait, so the object is just an instance variable, and if you call for real object, then it's just saying, did I resolve it from the transaction? And if not, so the object has the object ID, that's the address of the database. I'm saying if I did not resolve the object, I just go to the transaction saying, give me the object with that address. And then it does not understand, it just dispatches then. So it just gets the real object and dispatches the method to that. So you don't recognize really that there is a proxy usually, because you just get usually. So unless you do equals or equals, you won't see it, I guess. But equals and equals are a bit of a problem. So that's a special section.
Given you have that proxy, I think it's possible for, I can't remember the terminology, but the visualizer in the inspector in Pharo, if you write one of those, you can do something special for your proxy so that it doesn't resolve itself until you kind of double click on it or something. I've done that in the past, but I can't remember how I did it. So a while ago.
Yeah.
But is it worth it?
Yeah, I didn't have, well, yeah, if I would have time, I would make it
Yeah.
because it's always getting, because sometimes I really want to know, is it a proxy or not? Yeah.
Okay. Yeah, I'll if I find my snippet of code, I'll send it over to you.
Yeah. So the make root, so I hope it was understandable. It just makes a separately stored object in the database. Yeah. So I also, from coming from Voyage, there's also a class method. I think it's called isSoilRoot. So you can override that with true if you want to make sure that all instances of that class are root objects. But make root can really, you can make that bunch of the same class make root and the other one's not. So it's really something you can, in your application, you can fine tune to a certain extent. All right. So MVCC, it's just a short demonstration. We have the heroes database. And the object should be still in there. Yes. I mean, it's database, right? So, and I just made an awkward stuff to remove every hero that has a level smaller than 5, just to get rid of some objects. And if you then open the transaction again, you see in the top there's 31. So it means 19 heroes are gone. Yeah. So that's what we expect and what I showed to you. But as with MVCC, there comes something called time travel back. So I know, looking at the soil journal, I just wrote the second transaction. So in the first one, there was the original heroes object. So if I do read version 1, I get the old 50 heroes. So that's the point, and you have to imagine, well, it looks a bit catchy, but you really need that. So if you have, what we have is an HTTP server. There is requests coming in at the same time. And what you want to make sure is that the view on your database is consistent throughout handling that request. What you don't want is that you get into someone else, commit some data, and then you read that because the proxy resolves, and then you get that new one because it totally mix matches that. And MVCC, with that approach, with the read version, it makes sure you always see only the object that existed at that point. Or, yeah, well, even if you remove them, that's why I showed with the remove, because that's a more special case that the object that have been removed, then again, they're there because they were there at that time. And this is an effect that every object change that is written to the database is appended to the file, but inside it has a position to the record that was before it, and stamped with the database version. So whenever you go there, it can go to, it reads the newest and saying, okay, but this is newer than my read version. And then it goes down the chain until it finds an object that was visible at that time. And so you get, over a big model, you get a consistent view throughout. So, and even for long running stuff, the journal we saw, when it does not have the transaction in memory anymore, it even consults the journal and reloads entries to find what was the old value of that to reconstruct it. So it does a lot of that stuff, but it gives you a consistent view. Does it mean that for MVCC repeatable read isolation level? No. I'm not sure if I think there is a term which is called read isolation, which is the highest degree of things you can do. So I'm not sure. So either, if it's that, none of the RDBMS does it, by the way. Only so every Oracle, everything, it's turned off. So it can do it, but it turns off because they sell for performance. So if I'm wrong and it's a repeatable read, if your MS is repeatable read isolation level, I'm not sure I can answer that because I don't really get it. Well, it sounds like yes, but I'm not sure what's repeatable read isolation level means in RDBMS. So, but yeah, you can, as you saw, you can anytime you can open a transaction for that version, and then you get the state of that version. No matter, so there's no special thing right now. And if there would be 1,000 database versions, I could put here 500, and then you go back.
So what
Yeah.
happens if you make a change and then write?
Do
Does
that?
it get appended on the end?
No, you get an exception.
Oh, okay, all right.
No, you cannot commit. So the thing, yeah, phantom reads. I'm not sure I can recall what it really means. So maybe that's something we could also take off to discuss that, because I'm not a super database expert. So I read all that stuff, but I never get it. Yes, Casper. Yeah, that's exactly the point why I'll also do it. And in the next presentation, there could be that one point is that the DSL for querying the database is using Smalltalk. And also just having like a dictionary where you're saying the query just uses the methods on the object, even if they're not on disk. Because every RDBMS, it's just, you need to materialize the data anyway to look at it. If that's the case, if it matches your query. And that's the same, but then you have the objects already. Yeah. And then you can just ask the objects. And that's exactly the point, that you're saying, okay, you have with the indexes, you have always something like a gemstone, the curly brace stuff. At one point, you cannot make everything Smalltalkish. Then you need to do a little bit detours, and it doesn't look a bit odd. But the plan is even for so there's another thing I'm developing that's called partial indexes. That means that if you have a huge collection, and you have a filter set on that, which is usually for a query, yeah, then the index will shrink to that object that only convey to the filter, and then it gets pretty small. And also the sorting will be irrelevant, because you can have it both. And then it's just like from a big data query having a subset which you need for your case, and then you just iterate over the objects and make something with them. And it's not just querying. You could always do side effects. So there is no exception to saying, oh, it's like a structure like in SQL, and I have to match the data. No, you can't. This method calls. You get it from disk. It's materialized. You call it a method, and usually for a predicate like a select, it will answer true or false. Yeah, but there is no. So there's use cases, and I cannot come up with. But I wanted to have something which can support all of that stuff. How much work was it to add the inspector tools? That's super easy, right?
Yeah, you can show them the code, can't you? It's quite.
Yeah.
That's one of the fun bits, Rafi.
Yeah. So so if you have an inspector Pragma, wait, I'm looking for a big one. Yeah. So you name it, that's the title of the tab that you get. And then you have a builder, then you're saying, okay, I'm making inspect a table, and then you add your columns stuff with sorting. That's it. And if you stamp on that object, it will have all the inspectors for that object. It will collect that. Some come from object, like the raw view, and then you can add for every class, you can add your stuff, and then it's just shown. It's like it's perfect. Yeah. So I think that the whole thing about GT Glamorous Toolkit, they live with it, and that's really good. So sadly, we're a bit inferior to that, but the idea is exactly what you want. Yeah. Yeah, exactly. So I'm seeing here, if there's anything more to show. Yeah, I have the well, skip list. So if you start using a big thing, then you have something like like to do it a bit different, because if you go low level, then and this is to be fast, so you have restrictions on the number, the key size, how big the key can be. Yeah, sometimes it's not a problem, but you cannot make it fast and flexible that way. Max level is something to skip list, which because it's a layered linked list, so you just give it the number of stuff which resembles a bit the amount of objects you want to store in that. So, but from that on, everything works just like the internal dictionary, the Smalltalk dictionary. There's another dictionary in Soil called Persistent Dictionary, which optimizes a bit the storage. It only stores the keys, and every value is a standalone object, a database address. So it makes that proficient. And skipless dictionary and B-tree dictionary are to the basic protocol, add, put, and stuff. They work all the same. It's just on a different level of efficiency or performance that you need, that you choose one or the other. Okay. Yeah, just here. So just saying that this example here, the hero 23 is like this add, there was a binary search. So even if there would have millions of indexes here, it would just go snappy like this. All right. A few fun bits or something. So maybe one thing. What impressed me also the most is, well, you're always a Smalltalk. You have the impression if you refile things correctly, if you compose them correctly, you can solve a lot of big problems. And the one thing is that Soil reads from disk. I mean, every database does this. And that's something you really want to avoid, right? And then we have the Soil object segment. That's the thing where objects get stored. And this has only two methods, add and add put. Yeah. Add put is a bit. Where's add put? Where is it? Sometimes you get confused yourself. So anyway, and then in order to speed up the whole database 10 to 100 times was just by subclassing the database, and then you the segment, and then you just make a least recently used cache. You're saying if the interface for the object segment writing to disk is add and add put, everything comes by here. So that means that in order to make a cache in the Pharo Smalltalk, this is all you have to do. So you have the least recently used cache, and then you're saying, okay, either I have it in the cache, if not, I call super, and then it gets read from disk. So that eliminates all file system reads within a few seconds. And so that's the, if you see that here, wait. So you see here the clustered records. So here fetched is the attempt to get an object. Cache hits, so you see from 58K requests getting a cluster, 57 were resolved from the cache. And actually only 1K was read and 151 records were written. This is where the real potential of all modern databases is, keeping things in memory. And still keep it in memory. So you cannot optimize writes. Well, you optimize writes when you're able to lose data, but you can always reduce reads. And here it's just the implementation. It's this. So you see here, it's just saying you store it on disk and then you put it in a cache. So that means if you read something and you write it, it gets exchanged with the new one. The thing that you write to disk, you just keep in a cache, and then the next one that comes reading it just gets the memory cached thing. And that's all that if you have a black box remote system, a database, you eat or die. Yeah. But if you have an object system like in a database, you can make all these funky special use cases yourself. And that's what I want. I wanted this is supposed to be a journey, and all this garbage collection what I came up with that makes itself while running and stuff. This is all something because everything is object still. And if you have a stupid idea, you can just put it in. Yeah. And
And
some of these,
it was an LRU cache, right? So it sort of ejects things at
yes,
some threshold. Yeah.
yeah, that's the,
Yep.
and it has a nice option that it can handle itself a bit of synchronization, and then
Nice.
then you're done. Actually, I'm not saying. I mean, if the reads are active, 95 to 98% of all reads are cached, which makes it really, really fast.
Your dashboard, was that Prometheus?
Yeah.
And what? And you're logging some of these stats, and so you're reading them into Prometheus to give yourself some nice visualizations.
Yes. Yeah. Yeah.
Cool. Nice.
Yeah. Well, I do this for a long time, saying if you don't have the metrics, I mean,
Yeah.
you see here the cache, how many clusters are cached. If you don't have that, so I have that down to the level that you have Pharo VM allocation and incremental GC time, GC, how many full GCs, incremental GCs, and how many time it spends inside. Without that, it's really hard because you always do stupid things and then some of that goes really up. I had the problem that I had, I think, up to 8 full GCs per second, which is not what you want to have. And then you get into.
And so what, are you just logging these stats out so that Prometheus can consume them, or have you got some API that can?
There's an API, it's called.
Oh, okay.
I look for a Pharo metrics. Well, it's a stupid little package I did.
We're signing you up for another talk, Norbert. Actually, I think that's another one for another day. That's really cool. Actually, that's very nice.
Yeah, because it's easy because the Smalltalk VM. So if you look at the virtual machine object in Pharo, there's plenty of methods with low-level VM parameters that you can just read. And then you make just an HTTP request stuff that just collects that stuff and makes this Prometheus format. And that's all you have to do. And then it just goes, it comes by every 20 seconds or 1.5 minutes, no matter what. And then after weeks, you just have that at your hand.
Which is lovely. That's amazing.
Yeah. And yeah, the code is stupid, so I need to redo. So there is a kind of a redo of this metric stuff. I might present next ESAC if there will be an ESAC. Yeah, there's always plenty of stuff, we all know that. All right, that would be my package. If there's any more questions, I'm open to answer them here or offline.
I'm interested in the querying then. So like you mentioned indexing, and I mean, is it just normal select statements that you're on your own, or are there ways of finding like, all the last names that begin with HE or something, or?
Okay. It's a topic for a known presentation. No, yeah, we started. I mean, the dictionary case that we have is easy because you always have a key. You have a key that you know. So the next thing with the secondary indexes is in the first basic form you will have an object index. We're saying I can store objects into, and then you make an index saying this selector makes an index, and then you go every time you store an object. It goes to the primary index, and then you see, there's a secondary index. It calls the selector and takes that value for the other index as key.
Okay.
Oh, and then that's just like in every other database as well. So you just have properties of your stored data, and then it's just saying, okay, I want to have an index of these or these two properties, ascending, descending, or something, and then you just make that that the quality you're searching for is binary sorted. It's sorted.
Okay.
And then you can have binary search. So this is what makes all databases fast. It's like have the criteria you use the most sorted, so you can have a binary search, and that's the thing. And that's also with the partial indexes, as I told, is that the The problem is always the point where you jump in. So that the indexes we have, you can find the nearest key that you don't have. So in database lingo, you just say that you don't want to have linear scan. A linear scan always means I need to start from the very first and scan till the end. And indexing and partial indexing and secondary indexes are all methodologies to circumvent that. So the goal is always like the file system reads. In order to get my subset of data reading the least amount of objects.
Right.
And this with all the indexes, you make that stuff.
So is that on the future list or is that in the current implementation? That was the bit that I didn't.
The meat future, which will be next year, will be that you have these indexes where it's only where you say there is a selector.
Okay, all right.
And then when you make a query, so there's usually a query analyzer in a database. So it looks at the query and then saying, oh, which of the indexes fits the best.
Okay.
So the final goal will be that query will decompose to AST. And from the AST, I derive the things that get accessed from that object.
Wow. Okay. So you're thinking pretty sophisticated then. Okay, cool. All right. So that just sort of matches you don't have any special syntax. You're just doing normal small talk things.
That's always the goal. Yeah. So I'm not sure if it will work, but that's the goal, that you have select statement with a block.
Cool.
The block gets decomposed. You can have the selectors. You have some algorithm that says, okay, this goes first. So you first use this index. Sometimes you use more than one index. And then you use this to select the index you have in your secondary indexes and saying this one is the fastest. And then you pick that. So it gets more of an automatic thing. But I don't know how much time I will have to get into that. But the easy thing is always saying, okay, usually you just have a getter selector that you use, and this is easy to do. And you're just saying, even in the query, you can saying, okay, now I wanna look at the last name and then do the query. It's the first step. It's stupid, but it gets you what you want. It gets the fast thing.
And if you dispatch back to something, you could always override it and add your own custom understanding if you need to. But no, that sounds really neat, actually. Wow.
Yeah. I mean, the good thing is if soil supports stuff, I don't have the idea about. So, but you have.
Yeah.
That would be the best goal. So, as long as soil does not get in your way, because soil is not a kind of a progression. It's a pain reliever. It's like we have to do persistence, but why does it need to be so painful all the time? Yeah. That's the point for me, because I don't take it anymore. So it's there. Let's assume I'd like to move my existing. Oh.
Converting. That's a good one.
Well, not converting.
Which one?
I mean, in my particular case, if you're looking at my question, what I would want to, the system I have, it involves a lot of searches between this date and this date. And of course, that's in relational databases, that's really quick. Just, most of the heavy lifting is done by the database itself. And then I read objects once I get the results, which sometimes it's just like 100 or maybe 10 objects. But if I have to scan through the whole database just to retrieve a certain range of dates, then that could be an issue or not. Maybe not, I don't know. How do you deal with that? Do you deal with that kind of dates and objects?
I don't know exactly what you mean.
Let's assume you have to search for objects within, I don't know, some documents created between this date and this date. So you have a database and you have a list.
Easy. I'll do that. So you
that.
just have a dictionary with the data as the index key.
Okay, yeah, that's.
So I'm a fan not of the full event sourcing package, but of the core essentials. So an Active Grid uses that pattern, just like that. Everything that gets alters emits an event which gets stored in a database. So which is so what we have in a journal, which is really low level. You have that on the application level the same, and this is indexed by date.
Oh,
So
perfect.
you just use a scheme like date and time as microseconds since epoch, probably. And then you have the number, and every index always uses a number as key. If you get it a string, it will make a byte array and a number out of it. It will something because a number is that thing that makes it sorted. Yeah. There's no
Mhm.
lexical sorting or something, but you can do all of these things. I wanted to do for ESAC even. I mean, there is these Hilbert curves thingy where how do you get a geo coordinate into a string? That's what MongoDB does. And then you could, with Soil, you could within a few days, you can make a geo database out of it. Because then you have the object which makes the Hilbert curve, the I don't know, geo hash. So you make a geo hash, and then you just use the rest. So when you look at this database stuff, you just see that no one is no one is doing magic. Yeah. So everyone, it's just always the same things. So I want to come back to the support of Windows. Yeah, Peter was asking. It's right before the door because last week there was Masami. I don't these Japanese names, so it's a really nice guy from Japan. I guess. I hope I don't. And he did it. So there's a pull request in Soil adding the file locking and stuff for Windows. It's just I don't have a clue about Windows. And there is the pull request is failing, the tests are failing on GitHub. So either this, and I asked Pablo because he's also really proficient Windows user. So one of these will check why it's fail because it's obviously it's green on this guy's computer, but it fails on GitHub. So when we resolve that, then Soil will have Windows support.
Wow, that's awesome. That's great because I use Linux and Windows, but depending on the use case, sometimes I really need Windows.
Yeah.
So I love what you've done with this. Question on on creating indexes. Can I create an index with multiple segments, or do I have to do that manually?
What do you mean by
Well,
segments?
let's say if I'm sorting on last name and full name, or let's say I want to sort last name, comma, first name.
Yeah.
Can I define an index with those two segments, or do I have to
Yeah,
actually append?
because it's not magic. Because usually, if you have a composed index, you just concat the strings, the
Yeah,
keys.
yeah.
So the basic what most databases do, they just concat. If you want to have an index on two categories, you just
Yeah.
concat. So,
But then do I have to have an extra definition for that attribute?
there will always be, well, I think we solve it with a kind of a getter you have on the object. You provide that, what key
Yeah.
to use,
Yeah.
and then it depends on you how you structure that key. So that the
So-
index doesn't do something for you. The index is just, okay, I need some kind of key representation. I need the object that I
Yeah.
can store. So, and then the object is responsible for making the right key. So in the case Esteban was querying, it just returns its date and time
Yeah.
to make the key. In your case, you will combine two qualities and or make something even weird. So as long as it can be turned into a number, the index will digest.
So if I wanted one segment to sort ascending and the next segment descending, for example, and then if I had duplicates, is that an issue right now?
The sorting we removed because, well, we designed, so even in the skip list and the B tree, you have usually forward links. You had a point to the next elements, but we just decided, and with the next, well, it's already there. We added backlinks. So that means even in the skip list, it always points back. That means that sorting is for free. So because usually in Postgres, something you have for, I think for ascending, descending, you need to have two indexes. And if we succeed with doing what we do, you can have one index and you can use it in descending and ascending manner. It's just that if you use an index, you use an index iterator, call it. And then it might be just that you call an forward or backward iterator. And then if you go to backward iterator and you go by next, it goes from top to down.
Okay.
I hope
So I love this session because I'm getting some real world tutorials on soil. Do you have any further documentation available yet?
Of course not.
Yeah.
I mean, that's always the weak point. It's not. So we have, no, actually not. Yeah. So it is, everyone, we wanted to do this all the time, but then, yeah. So, but we're available. So either on Discord, by email or something. So I'm really open to this because as well, these sessions is also good for me to learn what people want, think, and stuff. This can just improve the whole soil experience. So I
Yeah,
think as long as, huh?
I find examples are very useful. So what you've
Yeah,
just done, for example. So
send it to me. Uh, So there's all chlor-based system to soil deal with lookups that involve searching between certain. I hope that was answered. Russ was asking about stun safes. Stun is recursive savvy. Soil is not when you use a set that has a set as element, because Pharo does some strange things about calling something like a delegate something, and that always happens in the wrong moment in materialization. So if you have a set that contains sets, you will have an endless loop. So there's an issue, but that's, for me, it's a Pharo problem. And cyclic reference is not a problem, not at all.
Okay.
Neither inside the cluster nor outside. It will handle, well, it should be handled just transparent. I do this all the time because I have this thing with parent pointers and stuff. So that's the one thing in Voyage we always had to deal with, but soil just eats it. So it doesn't care much.
Right. And that's what I ran into with Voyage and MongoDB was was that recursive was just I
Yeah.
would have to rewrite 60% of what I had.
Yeah. Yeah. The problem with all these, I mean, the Mongo, they even removed after this version 2 or something, they had something like DB reference. Yeah. And I think they saw that they came into trouble and they removed it. So on the advice to all people on a document Mongo or at entity relation or SQL database is always that there is one, so that you think about queries. Yeah. So that the good thing about an entity relationship like SQL is you get always both sides at the same time. So you make one reference, really the reference, and the backward, the query. So that's usually how you avoid the problem. So in code, you have both. So you can navigate both sides, but only one points to the other. And a SQL query can always say, which is the one that points to me? So you get the backward by query. So, but yeah, I don't want to have to deal with that. So soil has, I never encountered anything well, apart from the set it set problem where we get into trouble with having circular references. Benoit wanted to talk about the concurrency in soil. That's easy. Well, no, it's not too easy because that's also people ask that. So soil, how I use it is that one database is only open by one image. So inside the image, all transactions are sequentialized by a semaphore. So one transaction can always be committed at the same time. That's in every database, that's the case. There is I'm not sure if it's a ephemeron problem in Pharo. So there's another thing that in Unix, if you have file locking, yeah. In Unix, the semantics are that Unix says, as long as it's in the same process, the process has to know better when there's a locking situation or not. So that means that if there comes file locking from the same process, Unix will just ignore it. So soil has an in-image tracking of references. So you could even, if you would have multiple soil object instances in the same image, you could track that. But I always got into trouble because the weak collection did not get cleaned up properly. So then I didn't work on it anymore. Even having multiple images accessing the same file should work. but my setup is also invoking NFS and all that stuff, and I get into multiple trouble, so I stopped just tracking it. So I was saying, so multiple image, I would not do it, but we can look into it. But with the caching in one image, it's not preferable to do that because the one image with the object with cluster cache is so much faster than a lot of images. That is something I thought that most people do wrong, that more images is faster. It's not necessarily, because if you have multiple sources of truth, you cannot cache something in one image because then it gets out of sync. So it depends a bit on your sim. So from the in-image perspective, from the green thread perspective, Soil should be fully concurrent safe. So there's nothing you can do. So, and in my situation is like in a sync server, every HTTP request is a Smalltalk process. And a transaction is attached to that process. And so we have multiple processes, each having a transaction working on that, but that's supported. That should work fully.
So,
Not
so
sure.
for the scale of your app, then is it one image is the database? Is that
No.
how? No.
One image has multiple. So we have so that's another talk where I'm always saying is the only valid scheme for scaling is partitioning. Yeah.
Right.
So you can have a lot of database do sharding. That's a logical partitioning. Yeah. But if you can partition and in a database, in an application like me, we have now I think up to 7,000 users.
Right.
Yeah. So there's a scaling potential because it's 7,000 things. So, and that's every user has its own database, but
Okay.
an image can open multiple databases.
Okay.
So I can show you. It's well in afternoon or something. We have until 100 databases overall. I think right now we have 8 Pharo images, so it's like 10 to 12 databases per image. And
Okay.
I guess, well, it depends on the architecture because we keep the database open for a long time because it's the object that keeps the cache. So we can
Right.
for
Okay. Yeah.
multiple hours we just keep it in memory to keep the cache. If it comes back, the cached objects are still there. But you can go easily up to, I think, 100 databases per image is feasible. Because usually the access is so there's no one hammering on the image all night. It's in normal usage, there's so many breaks in between that you can easily fill 10 to 100 databases. That's supported. That should be. It's a different set of files, different set of database objects, transactions. So this is so we just have one single database registry, we call it, so where we keep them so that the reference so the database stays open.
Gotcha.
And
Okay. All right.
And that has an idle time, and then when the idle time gets exceeded, so we close it. So you open it, and then a few hours later, if there was no something, it gets closed. So you have an average open user day, which maximizes the use of your cache, but don't waste its memory for nothing. So, but that's the architecture of your application for sure.
Yeah. Yeah.
So that's interesting on scaling number of databases and users. But what about a single database? What's using Omnibase? There's kind of a limit of how big a database could be. What's the limits with Soil?
Well, it's the same. That the point in Omnibase was just it was pretty much 32-bit because it was from 98, which was feasible at that time. Soil is 64-bit, so not sure if you get in any trouble soon. So there is, I mean, from the object pointer, so we have a combined object pointer where the segment takes a few bits and the object takes a few bits. So right now, I think the segment is something like 4 bits or 8, I don't know, and the rest is for the object. So there is not a real restriction. So in the end, I also want this threshold. So how many bits is a marker that you should configure? I'm not sure if I did it already. So you decide when you open a database, you're just saying, okay, I want to have 0 bits for segments, or I want to have 32 bits for segments, and the rest is IDs, but 64-bit. I mean, Pharo has only 60-bit open.
Yeah.
So
Good.
I can do that. If you find a disk that big.
Mm-hmm. They are getting big though. They are getting big.
Yeah. So, well, 200 gigabytes. I can show you. I have one which is 200 gigabytes. There is no, I'm not sure. So we removed all the restriction. The restriction were that Pharo also used it, all Unix calls, which were limited, that you just can have 1024 files open and such. But I don't, all of that removed. I don't see any reason why there should be a limit. We have in the index, we have 32-bit pages, which is 4K, and each page is 250 entries, something like this. So you have maybe 100 gigabyte, 100 billion of entries or something, and then. But if we come to that problem, we can solve that. It's
So for your concurrency, are you tracking at the object level or at the page level? How granular is the concurrency?
concurrency is per object. That's what I told at the beginning. So right now you have to use that mark dirty call. So to see which object it changed. So you have it yourself. And I want to exchange that with the object state pattern. So it snapshots the state when you read it from disk. And then it checks on commit if that object has changed. And then the granularity is everything that changed.
So if you have nested objects, let's say you have person with a dictionary of addresses, but I changed the first name, does it not go out and save the addresses as well? And so like, how do you manage what part of the object gets saved if there's a big chain?
Okay, well, that's the most annoying part in Soil is because you have objects in your mind, but the objects are stored in these clusters. Huh? So cluster is a bunch of objects. So and that's why I want to get rid of that mark dirty, because if you change an object, you need to mark the cluster dirty. So this is if you have the heroes, for instance. The heroes is if I would not make the heroes root objects and everything is, then I change a hero, but I need to make the dictionary mark dirty. And that's a bit the design, how the cluster, how you submodel your stuff, that you have. I do these clusters, and then you have to know whatever you change in, you have to mark the cluster dirty, because that's the atomic thing that's get written. And that's I think maybe in version 5, I want to remove that. So every object that's read from disk is snapshotted with its state, and then it can track itself when an object changes what to save. So you don't have to care.
That's great.
Yeah, it's really awful. That's the one thing about Soil I don't like. That's a bit awful because it's two mental model that do not fit together. That is saying at one point I change one thing, but then I have to know something else where to put that, and it's a bit awkward. So I couldn't go the full range like Gemstone that every object is stored in an index and you can track each individually, because that's a whole different thing. So the cluster is kind of getting the graph to save smaller, but still have something combined that you don't waste that much addresses to make that. But yeah, this object state pattern, I don't think I think Claude does it as well. So at least Elliot told me, and then I was looking into it, and then I think I can do the same thing.
So one of the reasons I like object database is it's much faster. You're not assembling and disassembling objects into rows and columns. But I forgot my question. Just how much faster would you say object databases are, like Soil versus the same implementation, let's say for Heroes in a MySQL database?
I don't know. So the point is, and that's always what I tell the people. So if you have, the use case would be something like you have a list of heroes and you want to go to one. Yeah. So you have to resolve that relationship. And that's all the point saying. So if you have a website and you go that link to the hero, why do I have to join 2 million entries database together to find that single link. So I know that's the one thing. I mean, even if it's stupid at first place, that Postgres has to do this, but it's really good at doing this. So it's really fast doing all of that. So I don't have that. But in Soil, it's just like, I mean, you have to reference. You just go. I mean, you go there.
Yeah.
I think it's so with the memory caching and everything, and taking into account that Pharo, I mean, Smalltalk is not the fastest language out there. I think it's faster, but I cannot tell.
Yeah, I think in my experience, the more complex your relationships and the database becomes, the better objects are versus relational.
Yeah, I mean, I explain it usually. So there's two types of database usage. So an entity relationship thing is identity you get at query time. In object oriented, you get it at write time. So you have an identity like an object, and that you write, you manifest, and then you get the same thing back. In SQL, you always tell your properties and everything together with joins and stuff, what you want to get back, the thing. So that's a whole difference. And if you just model your database in a way that you use it, then it's pretty fast. Because then it's really that's what comes out of everything we do. And then you follow just a couple of references. And it's really hard to make it faster than this, I guess.
Yeah. Well, with relational, the problem is you have to design your database first to optimize it, and then you write the code that reads and writes it. And I think with Soil or object databases, it's like having unlimited RAM when you program.
I mean, that's the whole purpose of a database. It's like making a subset of everything on disk available in memory, so you can deal with it. The quality of a database is just how easy and how efficient you get that subset into memory. But yeah, I would like to know that numbers as well, how fast certain use cases. So, but then I mean, in Soil, making if a SQL query like going over 1 million user and collect a statistic of how many, that's pretty not easy with Soil. So you can make indexes to make that, but that's the real power of a SQL engine. Yeah? So I'm just saying for most of my use cases, or almost all, I need a navigational. I'm just saying the one is the query and the other one is the navigational access. And the navigational access is just a natural to objects. But yeah, I think it can be really fast, but I don't know. If you can do that in numbers, I would tell me. Partial reads.
I mean, the fact that you're using it for real in a real product is testament to the work you've done, actually.
Well, I wouldn't have done it if there wouldn't be the product. So it's just, well, I got into this Omni-based trap, and then there was no way out. But there is no way proceeding with Omni-base for certain reason. And what should I do? Going back to MongoDB or something, I was just done with all of that, and then it just popped up that I had no other chance. It was in production, it was failing. Yeah. So I had really bad sleep for months. But I'm just saying, okay, Omnibase is working so shitty. So how long can it take for me to get up a code base which is as shitty as this? Yeah. But with the quality that then I know how to fix it. So that was the initial idea.
I guess the fact that you knew it was possible in Smalltalk, like to just do it, you didn't need to write it in C or something.
Yeah,
that gave you the leg to kind of just say, right, I'll implement something equal, if and as it's turned out, perhaps better. So,
yeah, and in my history, cool. I had a lot of writing, serializing formats and stuff. So so that's also if you see all your expertise saying, okay, I don't know what's there, but I think most of that stuff you can do. And the deeper you get into, you see that most people make more out of databases what they really do.
Yeah.
So that's why my talk was called "There's no magic until you talk about databases." So
nice title. Very good.
Yeah. Benoit, can you support partial reads? What if you just want to retrieve the zip codes out of a gazillion addresses in a database for reporting purposes? You can do that. Well, if you have that same query a lot of times, then you will sooner or later you will make an index for exactly that thing. So if you're saying you have a special quality, you want to have them, you make an index and then it's maintained, and when you request it, you just get fast stuff out. The rest is that you, for the indexes, we have an iterator where you can navigate a bit better through. So if there's characteristics about zip codes or something, you can jump to a few millions to that point and start reading, and then make the kind you read in the index according to your algorithm. So I think there's no general answer, but yeah, indexes is the most prominent. If you don't have alternating queries that change every day, or you are just a reading saying, Mike, I stored, well, at one point you decide how you store the object with which key, and you will choose a key which supports that. So jumping there, reading 5,000 keys, then jumping somewhere else, or do the index. Okay. I hope that answers most of that chat thingies. Any more questions? What if David, what if the image dies? That's something I explained before with the journal writing. So you can have, so the one thing every database they make it is like a few rules about databases or file systems is append only is the fastest. So random access of files is slow. Appending sequentially writing or reading is fast. So what you do is with the commands I showed in the, can you still see my Pharo?
Yep.
Yes.
Yep.
Yes.
So, so this is the journal. This is a one sequential file that is written on the file system. So now we see here the yeah. We created a demo. So that's something you learn about file descriptors in Unix. So it's still there, even if it's gone. So here you see that file. Yeah. So that's a journal. That's something. Every time you commit, the database writes a sequence of all these commands here. It writes them sequential to disk. So when the image dies, then next time it comes saying, nothing happens because something that didn't finish never gets to the heap. When the journal is written, you call an fsync, it's called in the file system, telling the operating system that you want to flash all in memory to the disk. So you can, at that point, you can ensure it's on disk. And then you start writing the same data to the heap. And when the image dies, then the next time, so there's this pointer here. That's the last checkpoint. That's kind of a cursor into the journal files and position. So, and when the heap is written at the end, it updates that pointer. So if it dies while writing the heap, next time it opens, it sees, okay, we were there. Then it goes looking in the journal if everything comes after that. And if so, it replaces that. I'm saying you have the transaction 53. You wrote it to the journal, it starts to write to the heap, and then the image dies. Then restart the image, it reads the soil, and then sees, okay, there's a transaction to replay it. And then the semantics is that all these actions are in a way that if they were half done before, if you redo them again, it's the same state. And so what it does is soil alpha sees there's another, and then it replays the transaction, and then it makes a new last checkpoint to that. That's what's happening. And that's the asset, the durable quality that you're saying. With that thing, there is it's really, well, let's say, it's really, really, really hard to come into a condition where the database goes broke.
I see. I think the question was more related to the fact that if your image serves one or multiple customers at once, and if it dies, you don't have any concurrent image that basically access the same data.
I have.
You need to have a mechanism how to start up the image and reply back to the customer query.
Okay, yeah. So for ActiveQuit, this is easy. So I mean, you have to, if you don't have something that restarts your image, you don't have a service because something will schedule the downtime for you. Yeah. So you have to restart that stuff. As long as you're on the same host, I mean, you can have multiple Pharo images on the same host. They can all access the file. So in my case,
Okay.
I have multiple machines and all databases are stored on an NFS, a network file share.
Okay.
So the files are just accessible for multiple machines. And then you have a load balancer, which just keeps the connection. Well, it makes a pinning. It knows which user is in which image. But if the connection dies, it sees, okay, it's then, and then it reallocates to another image. And then this image
Okay.
opens over the network, the same database. So that's the same way we
Perfect.
do. We have zero downtime deployments because you just start taking down the first image, update the code, the next one. And while you're doing this, the connections go and the load balancer reallocates the things to the new stuff. And as you shut down two, but then the first one is up again. And so you just
Okay.
roll through, they go down and up. And the only thing that might change is that the load balancer chooses now another Pharo image to open the. So the only thing you usually mention is probably 2 or 3 seconds delay in one request. That should be all.
Yeah. Great. Thank you.
Yeah. So Benoit replication, yeah, that's the Rhizome project. I was telling this was the new one. I would really have a lot of time to do this. I have the basic setup, well, taken from Cassandra because it works there the same way. So it will be that images will use gossip protocols, it's called, to communicate state all over all Pharo images. And then the journal file that's written to the disk is a byte array that you write to disk. And this is also possible just to get sent over network to another database and then you have replication. So what it will be in the end is there's multiple Pharo images. They have a data layer among all Pharo images where they communicate states. And then with all that images, there is algorithms that detect if something is down. They work collaboratively to see if something is down, and then you get something, a primary gets saying the secondary takes over. That's the fault detection. And then you just have to cycle this sending of this journal. Transaction commit makes this journal entry, and then you store it just to a secondary database that applies it to the database, and then you have the database in sync. The heavy part is just to make or to write tests about that because it's distributed computing then, and everything can happen. And then you need to come up with something to get out of trouble out of any such network outage, host down, Pharo image down, whatever. We know that. So it's not reliable. But yeah, there's pretty big plans for replication and everything is in place. So I have the bits I need. It's just that I don't have time to start plugging it together. Okay. Wow, I thought it's 45 minutes.
I told you, people are interested. It's good stuff.
Okay, yeah, glad.
I think
Glad we
for
talked.
Smalltalk, it's very important to have a solid object database. I'm really happy you've done this, so thank you.
Me too. I'll sleep good again.
And there's lots of other interesting stuff in your project as well that we
Yes.
might unpick in future. But yeah, no, really appreciate it. Thank you.
Yeah, my pleasure. Okay.
I'm actually secretly hoping that when the ZAG Smalltalk that is going to enable use of multiple CPUs for the VM, I'm hoping that will work with your soil database. He's still, I don't know how far off before he's done, but that's another big deal for Smalltalk, I think.
Yeah, but so the more I look into it, you have this, you need all databases, they need a CAS action, so compare and set. So it boils down that you have with all the, if you don't want to, I mean, there's a lot in Java also. There's a lot of people that use multiple threads, but then the programming is in a way that you never sure. And then you have a lot of semaphores or monitors. And then you just block everyone. You have a lot of CPUs, but everyone is blocking everyone, and don't get really the performance. And so there is a lot of error of log-free structures. So there is structures in B trees and stuff. They don't need logs. So that's the point that pops up. That if you can do that, you really need not to just semaphores. It's not the best way of doing it. Yeah. So because everyone has to wait all the time because someone wants to do something. And if you can do this like the transactions we have, you can make it time shifted. So like I copied the thing in Gemstone, because you're saying the network is unreliable. And if we have a transaction conflict, I just wait 100 milliseconds and do the same request again. Just like let's pretend it came 100 milliseconds later. And so you solve a lot of problems, but yeah, you need to get out of the syncing hell or synchronizing hell. So, but yeah, it's a wonderful topic. So for me, I'm looking into sharing state over shared memory between multiple Pharo images, but that's something like a project for I don't know after retirement probably. Okay. Thank you very much for listening.
Yeah, no, thank you for presenting. Thank you for attending, everyone. And if anyone's got any ideas for other future talks, I might hit Norbert up for another one, and we'll get Giovanni on the booking case. But that other people have got other interesting things to talk about, so please do offer them up. There's definitely a willing interest, and it's inspiring. So thank you, everyone.
Yeah, I just posted my email on the chat, so don't be reluctant if you have any questions or suggestions for soil. Just take the email and then just email me. Yeah, so I'm always good. Exchange is always good for both sides. So I learn a lot. So
and you're pretty active on Discord as well, aren't you? I seem to recall.
Yes.
So
yeah, Discord is the easiest way.
Yeah.
So I'm almost always online. Thank you very much.
Right. I think it's getting late for you, Norbert. So
Yeah.
if everyone else is cool, we'll call it a night tonight, and I'll see you next month.